They are going to be talking about mining the seabed, and they wrote a very interesting white paper, which I really encourage everyone to read, and I think we're going to get some great insights. So I think I will hand over to Tom to start, and I think he's going to do a short presentation, and then we're going to open up to questions. If you have questions, please hold them to the end. You can raise your hand if you want to actually speak, or you can type them into the chat. Either will work. So I will hand over to Tom. Thank you again for doing this, and please go ahead.
All right, thank you. Thank you very much. Actually, Fabian and I will be tag teaming this. So we'll kind of go back and forth. So RAND, first of all, for those of you who don't know, is an independent nonprofit research organization. So we're sort of like a research consultants primarily for the government. We don't advocate. We're nonpartisan, objective, and we've been looking at seabed mining for a few years now, and decided to look into a few specific questions on the topic. Today we're going to present the results of a report we did. Interestingly, we finished it in December before the new administration took charge. So it doesn't the report doesn't comment on the executive order, but we'll bring it up today a little bit. And so let me just get going here. This is a pretty knowledgeable audience, so we're skipping most of the introduction. We'll go through this pretty quickly. Why the renewed interest in seabed mining? A big piece of it is the energy transition in response to climate change. That's leading to decarbonization, which is leading to electrification, which requires batteries. And we'll show a little bit about that in a second. At the same time, what we all have been thinking is imminent, maybe that's the wrong word now, development of a regulatory regime by the International Seabed Authority. That has sort of been right around the corner for several years now. And then finally, most recently, the new executive order from the Trump administration unleashing America's offshore critical minerals and resources. So that's sort of, as you all probably know, why seabed mining is of so much interest right now. Our analysis addressed 4 issues related to this. One is the potential impact of seabed mining on global supply chains for primarily nickel and cobalt. Another, we looked at a comparison of the supply and the expanded demand for nickel and cobalt through seabed mining compared to expanding junior terrestrial miners. Then we did an analysis on estimating the impact on income for terrestrial mining states, which is a big part of the ISA negotiations. We have not seen much research on that at all, so we decided to look into that. And then we have a big section on geopolitical implications of a global seabed mining industry. And so I'm going to pass it on to Fabian here to describe what we did.
Hi, folks. So here's a quick overview of our study design. We had 4 research tasks. Number 1 was to evaluate the potential for seabed mining to diversify critical mineral supply chains. In this respect, we chose to focus on battery supply chains. So some of the other demand signals from rare earth magnets or other technologies that have different demand for different set of minerals were not within the scope here. Our second task was to evaluate the opportunity and appetite for developing seabed mining in support of critical mineral supply chains that involved industry and government outreach, mostly through expert elicitation interviews. The third task was to evaluate the factors influencing the viability of the seabed mining industry. So that involved a little bit of both the expert elicitation, a little bit of industry analysis with a 5 forces framework. And then our fourth and final task was to look at the broader implications of establishing a global seabed mining industry And that's where our economic modeling in terms of impacts in developing country, terrestrial mining, revenue streams, as well as a workshop to look at the potential implications across the DIME framework, that's the diplomatic, information, and military and economic components of geopolitics. Some of the scope and assumptions, our focus was mainly on the nodule extraction and processing, mostly due to the higher commercial maturity of the nodule product. It has, in our estimation, lesser environmental uncertainty, and mostly the importance of the processing constraints within current critical mineral value chain nodes. Our demand signals for our 2040 scenarios are based off of existing incentives, such as those coming from the Inflation Reduction Act, and as well as the bipartisan infrastructure law that creates not just tax incentives, but also loan guarantees, and grants for infrastructure and products that require critical minerals and batteries specifically. Lastly, our workshop for the geopolitical impact took place in the 2035 scenario, assuming that extraction first took place in EEZs. So I'll go ahead. I'll hand it back to Tom.
Oh, okay. Well, I just want to give a nod to Fabian, who made this newspaper front page. It's all completely fabricated, but it was part of the workshop, kind of to set the stage. I thought it was really quite fun. You can see that in the report. It's in the appendix. So this, again, to a knowledgeable audience, is probably no surprise. Demand for battery metals is projected to skyrocket. What we're showing here is in thousands of tons per year, and in fact, the nickel, it's 10,000 tons per year. The demand in 2023, and then the projected demand in 2040. And you can see there's a lot of uncertainty. There's a great range between the low estimate and the high. But at a minimum, demand is projected to double by 2040. And in the case of cobalt, it could be as high as, I think, 14 times higher. So it's really pretty well accepted that demand for these metals is skyrocketing. And the other sort of stage setting piece, which again, I suspect many of you are familiar with, is that China is really dominating global supply chains of nickel, cobalt, as well as other minerals. This is showing for lithium, nickel, cobalt, and graphite, the market share by country for mining, material processing, and then for cell components in battery cells, the market share by country. And the red is China, the green is China, and the yellow is China. The green is Indonesia, not entirely, but largely operated by China. And the yellow is the Democratic Republic of Congo. Again, most of the operations there are dominated by China. So you can see China's really dominating the supply chains. The idea being that if seabed mining were to open up and start to supply some of these things, they could be controlled by other countries, and probably would be. We did a simple computation here, looking at how much demand seabed mining might meet. And what we're showing is the number of ships needed to supply the 2040 projected US nickel and cobalt demand. And this is based on plans from industry on how much production they would have per year per ship. We don't know exactly how many ships, but these are in the ballpark of numbers people are talking about. So it could be as few as 3 ships could be supplying the entire US projected demand for cobalt in 2040, and 11 for nickel, or it could be quite a bit higher. It could be 20 to 30 to meet that. None of those numbers are crazy high, and these are based on preliminary estimates. People don't really have super solid plans, and it doesn't include impossible metals model. So we didn't get to that. Not sure where you all would fall in here, but I'm sure we could add that in future work. So it's quite possible for seabed mining to really make a huge dent in global supply for nickel and cobalt. Okay, and now I'm going to pass it back to Fabian to talk a little bit about the barriers that seabed mining faces compared to junior terrestrial miners.
So when we were doing a walk through the industry analysis, the analog that we came up with for seabed miners was both in the junior terrestrial miners, that's the junior miners in the terrestrial domain. Those who are trying to explore and develop, but also once developed to find off-takers. And so this is where we made the comparison between the two and across a variety of factors. Here's a couple, just to illustrate a couple of the differences in terms of what operations might look like. When it comes to mineral concentration, it's clear that nickel, manganese concentrations within nodules are much higher than that in terms of terrestrial ores. When it comes to infrastructure cost and initial capital expenditures, developing a large mining site in the terrestrial domain requires a lot of infrastructure, roads, rail, port, energy, and power. All this infrastructure is needed and water is all needed to support the operations of a mine once underway. We're talking about a seabed operation, then you're basically carrying your infrastructure with you onto a ship, and it's the number of ships that becomes the limiting factor there. So in terms of capital expenditure, they're lower for the seabed case. When we start talking about regulatory barriers, once a regulatory regime is in place, then there's seemingly less regulatory and stakeholder pushback in the case of seabed mining than compared to terrestrial mines. In terrestrial mines, you might have local stakeholders, whether they're small populations, whether indigenous or not. The infrastructure that's needed to get to connect the mine and the output, just a logistical footprint for terrestrial mine brings in a lot of stakeholder input. When you're changing those operations to a ship-based operation, then there's less stakeholders involved. Maybe that includes a new set of stakeholders in terms of port ownership and port operations, but outside of some nonprofit entities that look at environmental concerns in the open seas, there are less stakeholders involved in terms of placing barriers to regulatory compliance. When it comes to public perception, of course, the seabed mining currently has a negative connotation in some senses. Terrestrial mining does have its own deficiencies when it comes to public perception, but it's more of a known factor when comparing the two. When we're talking about the offtake and the supply of products that are the demand signal for potential nodules, there's a couple of substitute problems that we need to take into account. That current battery chemistry is dominated by a couple of things, NMC or nickel manganese cobalt, as well as nickel cobalt aluminum. NCA chemistries are of course going to be the large demand signal, but they're competing against an alternative cathode chemistry in terms of lithium iron phosphate. And so that is the dominant chemistry in terms of cathode chemistries in terms of lithium ion battery technology. But if there were a substitute battery chemistry like a sodium ion, then that might displace overall lithium ion battery demand signals. And so when it comes to substitute products, seabed mining supports a fewer array of battery chemistries in that sense. But when seabed mining might reduce the demand for these alternative battery chemistries by making those NMC and NCA batteries more cost competitive if they're able to sell at lower prices and therefore compete more with not just sodium ion, but with lithium, not just with lithium iron phosphate, but potentially from alternative chemistries like sodium ion. If it can produce at these materials, these metals at lower costs, then the current chemistries for batteries then have some more staying power in the long run. And there's because there's a lot of manganese in these nodules, it also opens up the potential for manganese alternative battery chemistries that require more amounts of manganese. So instead of a lithium iron phosphate chemistry, in the future we might see a lithium manganese phosphate chemistry that could potentially give competition to Chinese firms that are producing lithium iron phosphate. When it comes to seabed mining equipment, currently there's uncertainty with respect to the operations of the long-term operation and sustainment of this equipment. Terrestrial mining equipment is well established and well understood. There's a large there's demand signal. There's established suppliers that have been servicing the industry for a long time. So there's greater uncertainty with respect to the equipment that seabed mining would rely upon. And lastly, there's the existing processors, the off-takers, are currently tuned to terrestrial ores, which means that there is a need for them to adapt their systems and processes to accommodate a nodule-based feedstock. But there are such processors out there that are seeking new opportunities. Those include traditional refineries. They also include non-traditional off-takers like potentially recycling battery cathode recyclers, who also can see feedstock from nodules. So you have these domestically in the U.S., you have them in Japan, you have them in a couple of different places. So with that, I'll hand it back to Tom.
Okay. Yeah. The next piece we looked at was the impact of seabed mining on income for terrestrial mining states. And what we did is we did a sort of case study analysis where we compared the revenue loss. So a lot of, let me back up. Again, I feel like this audience probably knows this pretty well. One of the concerns about seabed mining is the impact on prices and the impact on royalty revenue to countries that have a large fraction of their income coming from domestic terrestrial mining. So what we looked at the revenue loss resulting from price decrease, resulting from the supply increase from seabed mining. So seabed mining would, add supply that will depress prices, and countries that mine terrestrially will lose money. And then we compare that to the revenue gained from the ISA royalty sharing program, which would include both the royalty sharing and the economic assistance fund, neither of which is set, but we used a range of values for those factors. And we looked at the case of cobalt in the Democratic Republic of the Congo. And what we found is that no matter what assumptions you make, the Democratic Republic of Congo would lose money under a seabed mining scenario compared to a case without a seabed mining scenario. And we looked at four quadrants here. The vertical axis is the impact on terrestrial mining, and low impact on terrestrial mining means one ship out there mining. High impact on terrestrial mining means 10 ships out there mining. So that impacts the supply, and that impacts the impact on price. And then the horizontal axis is the assumptions about the royalty sharing. On the left, more conservative, less money coming from the ISA, and on the right is a more favorable royalty regime where the ISA is providing DRC more funds. And you can see in each case, the number is negative. This is the delta of the income in millions of dollars per year. And even in the most favorable case of one ship and a very generous royalty sharing regime, that's the lower right, we're still losing, DRC is still losing money. And in fact, we did a quick break-even analysis, and you'd have to go so far out to the right that the DRC would be getting, I've forgotten now the exact number, it's in our report, but well over half of all of the revenues, royalties, ISA royalties, from all of the mining operations in the world. So this is an important finding. Again, we don't believe we've seen this in the literature, that there's going to have to be some accommodation or some sort of acknowledgement at a minimum of this impact of seabed mining. Okay, next slide is, all right, so now I'm going to turn it back to Fabian. We had a really interesting and dynamic workshop looking at, perhaps somewhat speculative, but the really interesting potential geopolitical concerns of a global seabed mining industry. So Fabian, go ahead.
Yeah, so as mentioned earlier, we conducted a workshop, mostly consisting of internal grants needed, but a couple of U.S. government participants as well. This was a one-day affair where we introduced subjects to a 2035 scenario in which operations were already underway, mostly in EEZs, but getting started within the area, and asking participants to look at, to map out potential stakeholders, to look at the impacts and alignment of mining with critical minerals and broader U.S. Indo-Pacific strategy, as well as identifying potential impacts across the DIME framework, the diplomatic, information, military, and economic components, and then highlighting some priority issues, and then also contributing some potential actions to accompany those priorities. So we distill that into a couple of components here within those four elements of the DIME framework. Of course, you can read the report for the full list of bullet points. But in the diplomatic space, there's going to be some strains on international institutions, whether that is between an ISA regulated area conflicting with a U.S. Regime for international exploration and extraction, whether that is in extended shelf claims that overlap with other countries' claims, whether it is in EEZs that neighbor each other. There's going to be some diplomatic impacts that must be negated or mitigated through bilateral, minilateral, or multilateral institutions and mechanisms. And so these are when you're dealing with things in the maritime domain, there's definitely going to be impacts through diplomatic networks, and so diplomatic channels are going to have to be relied upon to reduce risk or just induce collaboration and cooperation overall, especially with the new industry with uncertainties with respect to environmental and long-term damage. So when it comes to the more of the geopolitical relationships in the Indo-Pacific, these will also have to be managed through existing relationships. There's, for example, a trilateral cooperation between the United States, Japan, and South Korea that includes cooperation on supply chains. Both Korea and Japan have presence in terms of seabed mining exploration and science conducted. But there's also other countries within the Indo-Pacific mini-lateral relationships like the Quad. So India, Japan, Australia, and the U.S. For example, India is another country that's interested in seabed mining, exploration, and science. So there are a couple of Indo-Pacific frameworks, diplomatic frameworks that could be leveraged or used as channels for cooperation on supply chains and potentially for seabed mining. When it comes to the information space, of course, there's still a lot of environmental impacts that are yet to be studied, but international cooperation on these could be an excellent avenue for bringing in allies and partners to the United States that are that are more wary towards a seabed mining industry, and of course, with a lot of uncertainty, creates areas for disinformation or information campaigns, which is something that has been seen inside of critical mineral supply chains and battery supply chains, both within the United States, within Australia, and likely in other areas, linked to cyber entities that have linked to the PRC. When it comes to the military aspect of things, of course, increased demand. There's depending on the level of market share by seabed firms, there will be an increased demand. There might be increases in demand for in the maritime domain awareness and security. If you recall, there was a dispute between China and Vietnam in the South China Sea over oil resources in the seabed that resulted in a diplomatic spat. We're not saying that there could be conflict over seabed mining or anything like that, but maybe you might see some sort of China Philippine style clashes and water fights with Coast Guard style shipping. There's also so that raises potential territorial disputes, and without a clear enforcement mechanism through the ISA or between two neighboring EEZs or disputed territorial claims, then there might be then this raises the possibility for a small scale conflict or gray zone activity, which would need to be mitigated through bilateral or multilateral channels. Finally, there's the economic impacts of great, like you just elaborated, the impacts to terrestrial mining countries that are reliant upon revenues is definitely a concern, especially if there's development goals associated with mining projects and development. These new influences on commodity prices and security of supply chains may shift in some cases. If we're talking about a scenario in which seabed mining dominates a large portion of the market, or a large portion of supply for a single country, then your constraining the number, the supply to a small number of ships, which could be targeted, right, for disruption. And so this opens up new areas for supply chain disruption potentially. The other is the uncertainties within the current regulatory enforcement and environmental monitoring. And so these economic impacts are yet to be discerned. There's also questions about whether the current countries that are more wary and resistant to seabed mining products, whether or not they would even accept these as these products and services within their country based off current opposition. Tom, can you click forward?
Yeah.
Yeah. So because the U.S. government is not a member to the ISA, then its influence is therefore pretty limited in some of these areas, and we highlight the need for engagement, with diplomatic engagement on bilateral, minilateral, and multilateral avenues and institutions. I'll hand it back to Tom.
Okay. So here we've added a slide on some potential implications of the executive order. It's got a few different things in it. I'm sure you've all are familiar with parts of it. Parts of it that we found were consistent with our findings, and we support that it acknowledges and recognizes and pursues the importance of developing nodule processing. The line I like to use is that all the nodules in the world, no matter what regulatory regime or place you mine them from, aren't going to do a thing for global supply chain diversification if they're all sent to China for processing, which is sort of, it's not the default, but it could happen if something else doesn't get started. And so it was good to see the executive order acknowledge that and start to develop plans for that. It also emphasizes the importance of working with allied partners. Sometimes some of these executive orders are focused very much on domestic only, U.S. only. This one did acknowledge the importance of working with allied partners in all aspects of developing a seabed mining industry. And then it also supported resource assessment and exploration in the U.S. EEZ and extended continental shelf, which is also something that came out of our workshop and our interviews with industry and government, that this is something that really needs to be extended. And we know Impossible Metals is involved in this. So that seems to be a really positive track. There is some cause for concern. It's speculative, but we thought we would highlight the potential issues of changing tracks from an international regulatory regime to the U.S. regulatory regime. For those of you who aren't familiar with it, the executive order orders the U.S. Department of Commerce to sort of dust off an old regulatory regime called the Deep Sea Hard Mineral Resources Act, DSHMRA, and start accepting applications for mining in areas beyond national jurisdiction that is the same area that the International Seabed Authority has regulatory oversight over. So this is introducing competing regulatory regimes in the same area that need to be deconflicted. Not sure how that's going to happen. Could raise problems, but at a minimum needs to be addressed. Even more speculative is this could taint U.S. products. It's possible that nations who really are opposed to this could treat U.S. mined minerals as somehow illicit and put restrictions on them. And then it could embolden others to follow suit, despite the fact that nations have publicly cried foul. One of those nations has committed many, many fouls. And so it's a little bit ironic that China would call out the US and saying, you know, you have to follow the rules. And so I'm not certain how much it would take or how little it would take to embolden China and others to follow suit. And if that happened, it could really weaken the ISA and could create increased sort of turmoil and amplify many of the geopolitical concerns that Fabian talked about in the previous slide. And then I think this is our final slide, recommendations for the US government. One is, now that we're proceeding with seabed mining, we think it's important for the US administration and Congress to determine if existing programs and policies adequately support the vision for seabed mining that's coming out of the White House, or if additional actions specifically targeting seabed mining are needed. Needs to clarify whether the cost of purchasing nodules extracted from the CCZ is eligible for the IRA tax credits. I'm not certain if that may have been kind of partly resolved, but at the time we wrote this, it was still unclear. And then, very importantly, accelerate efforts to map the seabed mineral resources in the US and US territories, EEZs, and extended continental shelf. And then for the second half, I'm going to turn it over to Fabian.
Thank you. So on the geopolitical front, we have a couple of recommendations here. Number one, consider ways to integrate developing nations into the industry that creates economic opportunities beyond just ISA royalty transfers. As we noted in the previous slides, the impacts to terrestrial mining and developing countries that are reliant upon these revenues to finance their fiscal and regular monetary policies is going to be impactful. And so finding ways to get them integrated within the industry, whether that's through different development on the processing side, whether that is in building relationships in terms of R&D and university collaborations, to find new ways to fund, to utilize their resources. These developing countries are gonna be impacted, and so finding ways to avoid instability in the long term, I think is pretty important. The second point I would recommend is working with allies and partners in preparation for potential bilateral or minilateral talks, even agreements or other types of cooperation on seabed mining. That could be on topics like the impacts to developing nations. It could be on scientific and environmental studies, impact studies. It could be on what kind of regulatory regime might be aligned with ISA. ISA's regulatory regime, whenever that comes about, whether it's resolving disputes over territorial claims, these types of things. It's going to have to be done through bilateral or minilateral talks, and so working with allies and partners through different diplomatic channels is going to be a necessity. The third point is to continue to monitor the ISA in its progress towards a regulatory regime, as well as monitoring the progress of other nations' seabed mining activity, notably that of our allies and partners, but also of China. And then lastly, to research the impacts of seabed mining on China's market share. Once a inflow of nodule products starts to hit market, we want to monitor how much of it is actually going towards how much offtake is going towards China's controlled processors, as well as cathode and cathode production, battery production, and other market share. We also recommend to research the impacts on the environment as well as other marine industries. One of the things that we didn't talk about earlier, but are in the geopolitical slide, was the potential impact of seabed mining on other ocean industries such as fisheries, tourism, and a couple of other things. These impacts are unknown, and so monitoring the potential impacts to important industries is important, is recommended, and any impacts to regional or local geopolitical issues, particularly in small island Pacific nations, and their relationships with China are of note to keep an eye on. Yeah. And with that, I'll hand it back to Tom.
All right. Well, that's it for our formal slides. So we can, I don't know, Oliver, what the typical format is, but I'll hand it back to you.
So why don't I have one question, but in the meantime, why don't people either type a question into the chat box or ideally use the raise hand icon, which is in the toolbar at the bottom. If you click the raise hand, and then we'll go to each person in order if there are questions. But in the meantime, let me ask a question and give a greeting. So first of all, thank you both, Tom and Fabian. I think this was a great summary, a great body of work that you've done here. I did put in the chat an announcement of the new battery chemistry that has been announced by both Ford and GM, which is a manganese with nickel with a tiny bit of cobalt. For me, I think is a very good fit for North America and plays quite nicely into deep sea mining nodules because of the manganese content. But my question, I very much liked your analysis on the economics, that the fact that basically when deep sea mining comes online, there will be more supply, and so prices are going to come down, and so that's going to ultimately result in less revenue to terrestrial mining. And so as a result of that, do you think it's reasonable that there is protection going on, i.e. terrestrial mining interests are lobbying hard to stop this industry and are potentially cloaking that in environmental concerns?
Wait, I think I missed the question in there. What was the question?
So the question is, are terrestrial mining interests lobbying and attempting to stop deep sea mining industry from starting, using environmental concerns to cloak actual economic concerns that this is going to have an impact to their business? And to me, this is very similar to Australian nickel mines that have basically gone into care and maintenance because Indonesian nickel mines came on market at a lower cost.
Well, we have to be pretty careful not to speculate on that. I mean, you know as much as we do about what the majors, they've been pretty quiet. I think Rio Tinto has made a statement, a pretty terse statement, that they're not supporting it. Seabed mining. If you're asking if they're sort of shadow supporting environmental groups, I have no idea. I mean, we know that some African nations at the ISA are slowing things down, but mining companies, I don't know.
Yeah,
I don't think we can speculate. I don't have any more information than you do about what they're doing.
Yeah, we are speculating, but I think it's logical that if a large amount of your business is going to be impacted by deep sea mining, it is likely that you would encourage this not to happen. And as we know, there is a very well-funded opposition to deep sea mining, but that's good for now. So maybe we can go to the first question from Jose. Do you want to unmute yourself and ask your question. Sorry, Jose, can you unmute and ask your question?
Can you hear me?
Yes.
Perfect. Thanks. Thanks, Tom and Fabian, for the presentation and for the very comprehensive report. I took very brief two-part question. The first part of the question is based on the report and what you've seen. Do you believe that at this stage, the question of whether seabed mining commercial scale comes online is a matter of when, not if it does? That's number one. Number two, in light of the executive order from the U.S. administration, when do you expect? I know that the report kind of makes some assumptions about when commercial production would start. When do you expect commercial production from the seabed could realistically begin? Thanks.
Wow. That's not really an empirical question. That's a tough one to get at. It all depends on you all. You know, the industry and the government need to come to terms. So it's seeming at the moment like momentum has shifted towards the industry proceeding, but we've seen over the last few years that goes back and forth. So it's really hard to say. It will probably move slower than industry wants, and faster than opposition wants. It's really hard to speculate.
Okay, next question is from Center for Community Law.
Thank you for this insightful presentation. Very interesting. As I expected, you did touch on the U.S. executive order, Trump's administration's executive order. But my main concern is from your recommendations, because it doesn't seem as if you foresee a strong regulatory position for the ISA going forward, because you said in one of them that to work with allies in preparation for potential bilateral and multilateral talks, which seems to be away from the multilateralism that we've known before now. And you also said to keep an eye on the ISA. So it seems as if you're already foreseeing a strong alternative to what the ISA is doing. Is there an empirical basis for that, or is it just the US position that informs, if I got you right, or is it just the US position that informed those recommendations?
Well, so keep in mind that recommendation, that was partly formulated, well, mostly formulated before the executive order, when under the Biden administration, the U.S. was a passive observer, and the vision for the U.S.'s role was primarily as a processor of nodules coming from other nations' operations. We don't mean to imply that the ISA shouldn't continue to run the show and be respected. That was not our intention at all. It was merely there's a lot going on, and the U.S., you know, being a non-member and a non-official negotiator, needed to basically continue in its role to participate and keep track of what's going on there. So no, we don't mean to imply in any way that the ISA is any less relevant than it was.
It's simply a matter of the U.S. not being a member of UNCLOS, and so there's limited recommendations for the U.S. to engage with the ISA, because it's simply an observer.
Great. Next question is from Priyanka. Do you please unmute and ask your question?
Hi, thanks so much for taking my question. I apologize if this was sort of addressed, but maybe I didn't pick up on this. I understand the executive order, and sort of that it paves open the doors for mining in international waters. But I'm curious, Oliver and others, you've talked about, potentially harnessing resources in the domestic waters and potentially trying to do that first. Sorry, it's just New York. So if that's the case, I mean, do you see that sort of happening first? And given the challenges that we've talked about in the international water space, that may still take time, and the domestic waters avenue is going to open up a lot sooner.
Again, that's a speculative question. 5 years ago, when I first started looking at this issue, it seemed to me that the ISA process was moving very slowly, and that I thought for sure EEZs would start to be mined before the CCZ or other areas beyond national jurisdiction. And over the last few years, we've heard Sweden, Norway, India, well, obviously the Cook Islands, Japan, they're all taking policy actions to open up exploration in their EEZs. So yeah, that may well happen. I think it depends a little bit on the resource potential in the EEZs, which to my knowledge is a lot less well known than the CCZ. Unfortunate those rhyme. The CCZ is much better characterized, I believe, than most of the EEZs. So there's a lot of uncertainty there, but it does free up nations from waiting on the ISA process.
If you don't mind, Tom, I would add a little flavor there.
Go ahead.
It is a very interesting dynamic, because in the areas beyond national jurisdiction, the CCZ, we have in some cases 20 years of exploration that has occurred. So there is actually now a lot of data, but we don't have a mining code that is finished, and there is uncertainty of whether it is actually being filibustered, whether the mining code can be finished. Now, in local jurisdictions, in EEZs, the Cook Islands is by far the most advanced. They have passed all their legislation, they have awarded free concessions, there is work progressing, so they could actually be the first. But then there is the wild card of the US with the current Trump administration, that with the executive order that wants to accelerate. And so it's not completely clear how quickly that could happen. So at this moment in time, I wouldn't want to bet. It's very difficult to say which of those would happen first.
In terms of our workshop, we made the assumption that the EEZ would be the first domain in which seabed mining first started, and then followed by ISA production. Again, that's just a scenario with a couple of assumptions that a domestic regulatory regime is easier to navigate, but it doesn't consider the resources mapped exploration that still needs to be done, and these other real world barriers that need to be accounted for that.
So Eric is next.
Sorry. Could I just ask, Tom and Oliver, you talked about the characterization of the nodules, for instance, in lesser known in the domestic space, in the EEZs. Is there work that's ongoing to characterize these nodules better in the EEZs?
Yes, I would say the Cook Islands is the most advanced. They passed legislation many years ago, establishing their domestic regulator, the Seabed Minerals Authority, and that authority awarded free exploration licensed areas in, I believe, 2022. And each of them have now been running a campaign of environmental baseline and resource definition. And typically, at least 5 years of that data is required, and so they're at least halfway through that. So that is, I would say, in EEZs, that is the most advanced. But as Tom mentioned, there are many other countries that are in the process of starting as well.
And the U.S. Geological Survey does already have efforts to map out resources in some areas.
Yeah, I'm conscious I want to get to everyone's questions. So Eric, do you want to go ahead?
Yes, thank you. I was wondering whether or not your report also looked at modeling the processing and refining capabilities and capacities needed to support the deep sea mining. What is needed to come online to support the figures you're bringing forward?
Yeah, we looked into that actually in some detail, probably detail that went beyond some of our understanding. But the gist of it is most of the nickel in the world is used for steel, and the processing is tuned for that, which makes an alloy, and then the alloy is sold to steel makers. If you want to make batteries, which is a much smaller fraction of the nickel in the world, you need to make a mat, you need to put a sulfidizer or sulfidation piece onto the end of your processing unit. It can be done, but right now there's so much money in the steel nickel that there's little incentive to do that. So hopefully as the demand for batteries increases, presumably as the demand for batteries increases, processing capacity will begin to shift more towards the battery materials. But right now, that's not really happening, certainly not in Indonesia. A little bit, but not very much. And there's a little bit in New Caledonia. But that said, when Indonesia banned the export of nickel ore in the teens and finally permanently in, I think, 2020, they're the major producer of nickel ore by far. That basically incentivized China, who was processing most of Indonesia's nickel, to move all their operations from China to Indonesia. And then their processing capacity in China, as well as the processing capacity elsewhere around the world, was running at way below capacity because the supply from Indonesia was cut off. And so there are a lot of processing outfits out there, as well as those that are attached to a mine, sort of captive processing, and the mines run out. And there's various situations where processors are wanting ore. So they have an incentive to modify their operations to work with nodules. But there's nothing tuned for nodules out there, but it can be done. It just needs to be done. It's going to cost money, and it's going to take time. It's not like a snap your fingers kind of thing. It's going to be a big effort. In my mind, still, although people are talking about it, finally, it's a huge fraction, huge portion of a mineral supply chain. Like a battery manufacturer can't use a nodule. They wouldn't know what to do with it. It needs to come as a purified compound, a sulfide or an oxide or a pure metal. So that step is critical, and it's still pretty fuzzy how that's all going to happen.
Yeah, I'll add one note in that in the long run, you need to add capacity. In the near term, there's kind of annual contracts to accepting offtake that are renewed, and so if there's production of nodules, they can get into that window of offtake agreement contracting and get a place amongst the current processors. Of course, that assumes that the production line is tuned to accept nodules. But if that were the case, you don't necessarily have to open up a new processor to offtake nodules. You should get in on some of the current processors because the way the contracting works is that they're renewed annually or on a periodic basis. And so once a contract is up, you can get in line for the next get in the queue for the next round of contracting.
So Tom and Fabian, we are at time, but we have two more people. Are you okay to take these two questions?
Yeah, I just let my 10 o'clock know I'm going to be there at 10:10. So
okay, let's quite quickly get these done. Really appreciate it. So David,
questions in the chat too that I think might have gotten overlooked.
Okay. Well, let's prioritize people live. So David, or maybe he dropped off. So maybe
No,
Chris.
I'm here.
Oh,
I'm
please.
here.
Yeah,
Yep.
please.
Thank you. Yeah, I did put a question in the chat, but I'll ask it directly. So this is what you've suggested is one approach to this issue of battery technology, but is there not another one? I mean, we're already seeing that the new battery technologies that minimize the use of cobalt and nickel are expanding much more quickly than perhaps was originally projected. So why not invest in those rather than investing in an industry that aims to displace those?
You know, when you always hear about a new battery technology that's taking, you know, industry by storm or this and that. My background is in material science, and I did battery research for a while before joining band and policy stuff. And commercialization of these new technologies is always the barrier. If you may have a chemistry that works at the coin cell level, you may be able to reproduce those results. If you need to also reproduce those results at whatever the form factor is going to be accepted, whether that's a pouch in a mobile electronic device like your cell phone or laptop, or if that's like a prismatic cell or a cylindrical cell in electric vehicles. You need to reproduce that battery chemistry in the format that's going to be utilized by your by the OEM, and you need to provide the data for the length of time that the OEM requires. So if the OEM, for example, my Polestar, right, has an 8-year warranty for its battery pack. If an OEM is going to offer an 8-year warranty for a battery pack, it needs to have 8 years worth of data, or it's going to want 8 years worth of data to back up its warranty, right? This is millions of dollars, potentially billions of dollars that this OEM is on the hook for by offering a warranty like this. And so you want to have established chemistries. You want to have they want to lower the risk at the end of the day. And so yes, there are alternative battery chemistries that minimize cobalt and nickel. There's one right now called lithium iron phosphate, right? Why not just go all in on lithium iron phosphate batteries if that's the case? But from the OEM perspective, right, they want to minimize their risk in terms of not accepting of being suspicious, or at least doing a lot of due diligence and collecting large amounts of data on new chemistries that haven't proven don't have as much data backing them up. So it takes time for a new battery chemistry to mature and to be commercially available. The folks that are trying to commercialize those chemistries are doing that, right? In the long, once that happens, then there's a demand signal that can be filled.
And again, just to emphasize the point Fabian made earlier in the presentation, you have to look at the incentive for changing chemistries. And much of the incentive is the cost or availability of nickel and cobalt. And if that incentive goes away, then there is less reason to go look at different chemistries. So it isn't always obvious how things are going to evolve. And our projections take into account, by the way, a large take-up of lithium iron phosphate in our demand projections for nickel and cobalt. That's already accounted for.
And I'd add 30 seconds that all battery chemistries have trade-offs. So there is no perfect solution that will win 100% of the market. LFP or iron phosphorus, although cheaper today than the nickel-based, it's also much heavier, which means that you get about 33% less range. Great for a Chinese car that stays in one city, not so great for a US or European that wants to do longer trips. So there's always trade-offs. No one chemistry will win 100%. Okay, maybe we go to Chris because we're quite a bit over, and then we'll wrap.
Hi, Chris Roper here. Thank you, gentlemen, for a very informative hour. much appreciated. Quick background on myself, so you know my question and where it comes from. Decade and a half as Saab's CI's North American seafloor resident tech salesperson here in North America. So lots of time deep, long. My question is for Oliver, and it comes to hardware, Oliver. Complementary of your design, complementary of your thinking and your approach. I think we're at a situation now where things are going to move forward. I am opposed, but I believe things will move forward. And I'm wondering, is there discussions within your organization about an industry group? Because Oliver, you got a great design that can be selective from what I read, but we've also got some bulldozers. And when you move forward, Oliver, which will happen, so will a bulldozer. And my concern is the precedent that gets set by good technology that is then followed by dig and burn technology. Comments on that as far as an industry group, because ISA is not going to do anything. An industry group that can monitor and govern yourselves?
So just quickly, I mean, we're open to working with anybody. You know, we would like our technology to be prolific. As you mentioned, it has environmental benefits, but we also believe it is at least a 2/3 less expensive than the traditional dredging tractor approach. And so we think in time that will be compelling, even if you're not concerned about the environment. So ultimately, we think, like all new technologies, they replace older technologies. And so our strategy is to try to make our approach the default for the industry.
Thanks. I got a plane above, which is probably going to be noisy. But again, back to the internal the discussions in your industry. Are you chatting with the likes of, say, the metals company or any of the other potentials about setting a standard for technology, a standard for equipment, so there is something that we can get our head around as far as the equipment proposed? Because right now it's all over the place. And it may well be. I mean, it might be it may not be a question you can answer.
Yeah, I mean, we have discussions with all of our peers in the industry, and as I said, we're open. But as a small company, we're focused on getting our technology out there and proven. We actually want to do a collector test. We have announced that we are working with BGR, the German contractor, and I think once that test is completed, people will actually have real data to compare our approach with others, and we think it will be compelling both environmentally, both economically, and also the fact that there's no single points of failure. But with that, we've taken so much time. I want to wrap up and really thank Tom and Fabian. This was a great webinar, great summary, and I would encourage everyone to read the full report. And thank you for your time and